Hi, everyone, and welcome back to another session of IGCSE Math Preparation Series. My name is Irfan, and today I have selected a bunch of past year paper questions regarding angle properties, and we're going to do them together. So please grab your calculator and let's solve these questions together. So question number one, we are given a pair of parallel lines. There are three unknown angles which I have to find. So there are no other information provided. So you can find X immediately according to opposite angles, or also known as vertically opposite angles. So X is 38, right? These two should be equal. And then if X is 38, this angle should be 38. That's corresponding angle, right? And if this is 38 and this is 24, this angle, because if you look at ABD, that forms a triangle, and we know the sum of internal angles of any triangle should be 180. You subtract 38 and 24 from 180, and that gives you 118. So this is 118. Maybe I write that down here. Okay, this is 118. And Z can be found simply by subtracting 118 from 180. So that would be 62 degrees, right? And also, since we found this angle, 118, it is same as Y, because they are corresponding angles. So this angle should be equal to this angle. So both of them are 118. So that's it. Moving on to the next question. So just remember I didn't use alternate angles here. Alternate angles means if this is X, this should be X as well. So I just use vertically opposite angles and also corresponding angles, and the fact the sum of all internal angles should be 180 for a triangle. So question number two, again, we have a pair of parallel lines. All right, so at first glance, we know that X should be 27. That is basically the alternate angles. So X is 27, that's what they ask. It carries only one mark. And the second part, they gave us the length of these sides, EH. So this is 5, and this guy here is 9 cm. So ZG, that is 7 here. So they probably asked for easy, this one, yeah. So if you recall from previous chapters, the similarity, these two triangles that you see, these two are similar because they are equiangular. So X is equal to 27. This angle, which we don't know its value and we don't really need that, should be equal to this according to the same theorem, right? Alternate angles. And these two angles should be equal, vertically opposite angles, right? These two should be equal and these two should be equal. So these two triangles are similar. If they're similar, there is a proportionality or ratio between their corresponding sides. The corresponding side for EZ is actually ZG, right? Let me call that Y. So Y over 7 should be equal to 5 over 9, right? That's the ratio you need to form. And if you do that, we get 3.9. You can round it to 1 dp. So it wasn't really difficult. All you had to do was just form this ratio. Moving on to the next question. So as you can see, they combine. If you go through the past year paper question, you see that they mix topics together. So, okay, we have to show that the angle ABD, this angle, is equal to angle ACB. As you can see, we have two triangles. If I prove that they both are similar, then they should be equiangular as well, right? because it works both ways. If you prove that two triangles are equiangulars, therefore they are similar, and vice versa. And I also know that they have one equal angle here. That would be ADB, and this angle. Angle ADB is equal to angle ABC from the bigger triangle. And then what else? We know that this angle is shared between them, right? The angle DAB from the smaller triangle, and by smaller, I mean this one, the blue one, and the bigger one maybe I label it, yeah, with the red color. So the angle DAB from the smaller triangle is equal to angle CAB from the bigger one. And lastly, they share a same side here. AB is actually shared between them. And according to AAS, right, they are similar. And if they are similar, therefore, you can conclude that these two angles, right, they are equal. So there is a similarity between these two triangles, and we prove that. And then same as previous question, we are provided with the length of the three sides. So we have AB, this one at the bottom, this is 12 cm. BC, this one is 11 cm, and AC is 16 cm, and they're asking to calculate the length BD. It's a little bit tricky here to form those ratios because 12 is shared between them. So don't forget that we're looking for BD. So BD divided by, you have to find the corresponding side of DB on the bigger triangle. So DB on the smaller triangle is opposite to angle A. So what is the side opposite to angle A on the bigger triangle? That is 11. So instead of this question mark, you put 11. That's what corresponding side means, guys. So opposite the same angle. And then now I have 12. Okay, 12, that's what I have. So 12 is opposite this angle, and the corresponding side on the bigger triangle is 16 because this angle, these two angles are equal, right? So that is 16. So this is the ratio that you have to construct, and then easily you can find the value of BD by multiplying 12 and 11, and then divide the answer by 16, which gives you 8.25 cm. So moving on to the next question. Okay, we have two pairs of parallel lines, these two, right, and these two. That forms a hexagon. That's also mentioned in the question. Okay, moving on, this is BC 32, this is 90. Okay, that's right there. Calculate the value of basically these four angles, the unknowns, which is also mentioned on the figure. Let's start with P. That's the easiest one. You can find that right away because these two, the angles around a point on a straight line should add up to 180. So 180 minus 32, that is P, which is 148, right? As simple as that. Then moving on to Q, I will mark this angle Y, and the value for angle Y should be 32 because these two are basically corresponding angles. If I extend these lines, then you would see it more clearly, right? These two should be 32. So if this is 32 and this is 90, I can find the supplement angle for Q, which is 58, right? And if that's 58, Q, you can just subtract 58 from 180, that is 122 degree. So that takes care of Q. And then moving on to X and T, isn't it? Yeah. If I extend these two lines, maybe I use another color so you would see it more clearly. Yeah, these two. And let me erase the unnecessary stuff. Okay. If these two lines, the green lines, are parallel, this and this should be equal. That means 100, this should be 148, right? And T should be 148 as well. All right. And we left only with X. So that should be an easy thing to find. If this is 90, this is known, P is 148, right? And what else? We have two X's here. So this is a hexagon. That's a hint right there. And you know the sum is actually 180 times 6 minus 2, right? N minus 2. So it's 6-sided polygon. So that is 4 times 180. That gives me 720. And I come here and subtract these values. 148, we have two of those, and 190, and then 122. That should give me 2x. So x is found to be 106, and that's it. Moving on to the next question. All right, this question and the next question is a little bit tricky, and you can see from the mark that it carries, 4 marks. So this is an octagon, but it's not the usual octagon that you're used to. The one that you're used to is actually a convex octagon, something like this. Okay, 4 sides here. So 4 sides. So yeah, this is a regular octagon. This is also a regular octagon because all sides, they have the same length, right? But this one is concave octagon and this one is a convex. So the concave one, they have a reflex angle as one or few of their interior angles. As you can see, these 4 angles, they are reflex, they are more than 180, whereas in convex, you don't see anything like that. So you might see obtuse angle, but for sure, you do not see a reflex angle in convex. However, the formula that says the sum of the interior angles should be 180 times n minus 2, where n is the number of sides, this works for both of them, okay? So regardless of their nature, whether they're convex or concave. Now, having said that, we need to find x. Since this is a regular octagon, this should be 32 as well, right? This should be 32, this should be 32. And maybe I call this y, okay? And this is 8-sided, so the sum of our interior angles should be 180 times 8 minus 2, and that means 1080. So 1080 minus 4 times 32, that gives me 4y, right? So the remaining, I have 4y and 432, they should add up to 180. So y is 238. So y is 238. And if you look at this point right here, x and y, they should add up to 360, right? The sum of all angles around a point. So basically one complete revolution, you're expecting to get 360. X plus 238 should give me 360. And x is 122, right? As simple as that. So we found x using this formula right here. So that works for both concave and convex polygons. The next question, okay, it's a little bit similar. What you can do, if you ignore this line here in the middle, if you exclude this one, FC in the middle, that would be a concave polygon, right? And the sum of the interior angles would be, and by that, I mean these angles. Let me label them with red. Right, all the way. These two in the middle are reflex angles. So we're looking at 180 times. So that is 7-sided, meaning which 7 minus 2, I should, okay, 900. And I got how many points here? I have 7 points. And in total, because at each point, one complete revolution, that means 360. So 7 times 360 is basically 2,520. And then if you subtract this from that, it gives us the value for A plus C plus D, E, F, and all the way to G, right? So 2,520 minus 900, that is the summation of all these angles, and that's the final answer, 1,620. So the key was to exclude the middle one. But if you don't do that, and if you treat as two separate polygons, then you're gonna have a problem at this point where they share a side. So you still can solve that, but there is one extra step. I suggest you to do it on your own, but that would be a little bit lengthier, right? Moving on to the next question. One angle of an isosceles triangle is 48. Write down the possible pairs of value for the remaining two angles. So why they say possible? Because the 48 that they gave us, we don't know if it's those identical angles or if that's the third one right here. So if it's one of those identicals, meaning which one triangle would be 48, 48, the third one is 180 minus those, so 84. Or if the 48 degree is the one unique angle here, not one of those twins angles, so that means 180 minus 48 and then divided by 2. So this is 66, this is 66. So another possible would be 48, 66, 66. That's what they asked basically. The remaining two angles, you can say 48 and 84, that's one possible way, and 66 and 66, that's another possible solution. Calculate the sum of interior angles of a pentagon. So pentagon is a 5-sided polygon. So just use this formula, n minus 2. N is 5. So you get 180 times 3, which is 540. So moving on to the next question. We have a trapezium. 4 angles are given. So we have to show that 7x plus 4y is 390. I'm going to use the formula of the interior angles of a polygon. In this case, that's a quadrilateral. The sum of all internal angles should be 360. So you just add all these 4 and equate it to 360. I'm sure we're going to get this equation. So 2x plus 5 plus 3y minus 20 plus 4x minus 5 plus x plus y minus 10. So how many x's I got? That is 7x right there. And 5, negative 20, negative 5, that's gone. That's negative 30. And then y, we have one here, another one there. So that is 4y. That should be equal to 360. You bring 30 to the other side, you get this formula that 7x plus 4y equals to 390. And now we have to show that 2x plus 3y is equal to 195. So how can we do that? This side doesn't help me because if I add these two, I don't get 2x. So these two, take a look at these two, according to alternate angles. So I'm going to extend this line. This angle and this angle should be equal. So this is 3y minus 20. And then these two together, they should be equal to 180. So 3y minus 20 plus 2x plus 5 should be 180. So therefore 2x plus 3y should be equal to, this is negative 15, goes to the other side, become positive 15 with 180, 195. So that's the second part. Moving on to solve this simultaneous equation. Well, they're referring to these two. So, okay, let's solve these two simultaneous equation. Let me write them down here. For y equals to 390, 2x plus 3y equals to 195. Well, you can use elimination if you want. I'm going to take the coefficient of y's, right? And I multiply this by 3, and I multiply this by 4. So I'm targeting y. I'm trying to eliminate y. If I do that, that gives me a pair of new equations. This is 21x plus 12y equals to 1170. And here I get 8x plus 12y equals to 780. So if I subtract 2 from 1, these two are gone. Here I'm left with 13x equals to 390. Therefore, x is 30. So you find x, and then you go back to either this equation or this equation, right? The original one. I think here is a better choice. So 2 times, we do that to find the other unknown, which is y. So 3y is equal to 195 minus 60, and y is equal to 135 divided by 3, which is 45. So y is found to be 45. Okay, so moving on to the last part. Use your answer to part D to find the sizes. Oh, that only carries 1 mark. Well, it's easy now that we have x and y. So having that in mind, now we can find the value of the angles. This should be basically 75 minus 10. That is 65. This should be 120 minus 5. That is 115. This should be 60 plus 5, and that is 65. And this should be 135 minus 20, 115 as well. Let me double check that very quickly. Yeah, all of them correct. So that's it. Having said that, I think we're done with today's topic. I hope you have enjoyed the video. Don't forget to make a comment and like the video. And I see you guys in the future videos. Thank you and stay safe.